And we're going to write an equation in exponential form. So remember, you'll have the equation there in the multiple choice options when you actually do this question. But what I would recommend to you, if you have to write an exponential model, we're going to make a little system. You're just going to grab 2 points. Thank you, thank you. Just grab any 2 points on the graph. If you have a point that does go through 0, which this one does, definitely use that point. So one of the points that's marked on there is 0, 3. If you can get one with 0, it'll make this so much easier to do. And then literally any other point on there. The scale on this is a little weird, so make sure you pay attention to that. I'm just going to grab the point 1, 6. Okay, now what you do if you have 0 as one of your coordinates, we can make a little system here, but if you have 0 as one of the coordinates, you can actually figure out the a value right away. So I'm just going to plug the coordinates into the actual exponential function for x and y. So y is 3 when x is 0. So we'd have 3 equals ab to the 0. Now anything to the 0 power is what? 1, right? So really, that's why if you can get a point that has 0, use that, because that just blows that out of the water, and then you have your a value. Now, you still need one of the other points to go back and figure out your b value. So again, I'm just going to repeat that process with one of the other points and plug in the x and y for x and y in that exponential model. So I'm going to write 6 equals. Now, because we used that other point real quick there, I knew the a value was 3. So I'm just going to put that in. So it'd be 3 times b to the first. And then all you have to do is figure out b, which will be really easy here. We just have to divide by 3 real quick. So the b value would be 2. Now, your actual answer, you got to write it in this format. So we would write y equals 3 times 2 to the x. And don't multiply the 3 and the 2 together, because in your order of operations, you got to do the exponent first. So I'm pretty sure that's one of the multiple choice options. It's like it'll say 6 to the x. Don't pick that. It has to be y equals ab to the x. And you multiply after you do the exponent in your order of operations. Does anybody have a question about that one? Okay. Now, let's see. You have to make a 5-digit, this is actually true. You have to make a 5-digit code for your taxes. If you are not allowed to repeat digits, how many codes are possible? So we're going to put, I'm just going to make 5 little blanks here, 5 numbers together. So it says you can make a 5 digits. How many digits, single digits, exist? I think some people messed this up when we did our probability unit. How many single digits do you have? There's 10. And I know that's weird, but it's 0 through 9, so it's actually 10 digits. Now, let's see. You're not allowed to repeat. So for the first one, I would have all 10 digits to pick from. If I can't repeat whatever number I just used, how many choices would we have for the second one? 9. And then it just keeps going down. So you've used another digit, then you'd only have 8, then you'd have 7, then you'd have 6. What do you do with those numbers? Add, subtract, multiply. Yep, you're going to multiply. Just multiply for each one, because it gives you a bunch of different options here. So I'm not on the screen, forgive. All right, so there would be 30,240 codes that people could make. Does anybody have a question? These are really mixed together. Sorry, these are all from different units as we've gone through here so far this morning. Okay, now number 15, this is from our rationals unit, wants us to solve this equation. What should I do first here? Anybody remember? Okay. Simplify the quadratic. Okay, so let's see what the factors are. Can you tell me 2 numbers, multiply, get you -6, add to get you 1? Like what would the 2, like I'm going to just cross that out real quick. What would the 2 factors be to put that in factored form? 3 and -2, and guess what? That matches the other 2 fractions. That happens a lot of the time. I don't want to say always, but it does. Okay, so I'm supposed to, on that left side, subtract those 2 fractions and set it equal to 1 over that quadratic that we just factored. How would you go about solving the actual equation? Like, what would you do as your next step? Because there's different ways you could do this. What do I need to add or subtract fractions? Common denominator. Okay, so what do you want to multiply the top and bottom of the first one by to get a common denominator? X minus 2. All right, and it's not going to cancel. What should I multiply the second one by? The x plus 3. Okay, now don't do this with an expression, but with an equation. And I know I wrote them in different orders, but you have x plus 3 and x minus 2 in the bottom of each of those lovely fractions. So you just cross the denominators on out because they would all stay the same if we're going to subtract those fractions on the left side. It forces the numerators of those fractions to be equal. Now, this is a tiny bit tricky. So I have to do like a foil or box, do that x minus 2 times x minus 2. Then you have minus 1 times x plus 3. And then we didn't have to do anything to the fraction that was on the right side because that already had that common denominator we were using. So let's just do this real quick. Foil or box, whatever you like better. You get, let's see, x squared minus 2x minus another 2x and then plus 4. And then because I'm subtracting, I would just distribute this like a negative 1. So it'd be minus x minus 3. And then we're just going to combine like terms. Excuse me. So we've got x squared minus 2 minus another 1. So it'd be minus 5x. And then 4 minus 3 would be 1. And then that's equal to 1. And anytime you want to solve a quadratic, make sure you try and set it equal to 0. We get x squared minus 5x. Actually, the ones would cancel. So I just get x squared minus 5x equals 0. Now, it's not a quadratic like a quadratic trinomial that we can factor. It's only got 2 terms. What could I do to factor x squared minus 5x? Pull out an x. Okay, sorry, I'm writing too big here. So just pull out an x. So we'd have x times x minus 5. What are my 2 answers? Okay, I thought I did it wrong. You guys were being quiet. Okay, 0 and 5. Now, before we for sure write those answers, this is a situation where you could have an extraneous solution. So I'm going to just look at the original problem real quick. X, if we got this as our answer, my restrictions on this would be negative 3 and positive 2. So just make sure that the answer you get is not something that would make a denominator 0. In this particular case, we're good. Both of these work. Neither one of these would plug in to make a denominator 0. So this question would have 2 answers. Does anybody have a question? Okay. Now this is like really snuck on here at the bottom of the page. So this says write an equation of translation of y equals negative 3 over x. So let me just sketch you a teeny tiny picture of what this would look like before we translate it. So if you have this irrational function, my variable's in the denominator. This is the situation where you create branches. It's not squared and that top number is negative. So just a tiny little sketch. The graph would have its branches in quadrants 2 and 4, and it would look something like that. Now, if you want to alter this, and this will be maybe a little easier when you guys do it on the actual test because it'll be multiple choice, but I want to alter this to move it 4 units left and 5 units down. Okay, now, any shifting left or right is not going to change the number on the top. So I'm going to leave that number on the top. The only time that would change is if it said reflection over the x-axis, and then you could flip that from a positive to a negative, but otherwise that number should stay the same. Okay, how would you put into that equation that you were going to go 4 units to the left? Like, where would that go? X, say that one more time. X plus 4, perfect. It's opposite of what it looks like. So I think that's what you said, but I didn't hear you. Now, 4 to the left is actually going to be plus 4. It's the opposite with the x. How would I do 5 units down? Just minus 5. Whatever goes left or right is the opposite of what it looks like because it's what sets that equal to 0. So negative 4 would cause that to be 0. That's what's actually going to move that 4 units to the left. And then whatever up or down, you just left or right is opposite with the x. up or down, just copy that number, and it should be to the side of the operation. In this case, we have a fraction, so we just put the -5 to the side. Okay, let me see what we have next. Oh, we haven't done these in a minute. This is also from the rationals unit. Maybe get on the screen here. All right, so I'm going to write an equation. What you have to remember on these, don't forget to put a constant of variation. We're going to put a k value. All right, so what I usually do with these, just so I don't forget, it says r varies. Remember, varies just turns into an equal sign. I just automatically put the k right after the equal sign so I don't forget it. And then it says jointly with t and s and inversely with the square of v. How could I finish translating that into an equation? Do you guys remember what jointly means? Yes, we're just multiplying. Jointly is just a direct relationship, but it's just it's two or more variables. So you would just do like TS, and then inversely, just remember inversely just puts whatever variable that is in the denominator. This is a little tricky. It says the square of V. So when I plug that in, it would be written as V squared. Okay, now they're going to give you just enough information to figure out your K value. So we're just going to plug these numbers in. It says when T is 3, S is 18, V is 5, R is 3.78. So I'm going to put 3.78. The only variable here will be K. T is 3, S is 18, and then V is 5, but don't forget the V was squared. Now, however you want to do this, I'm just going to do it right on my calculator because I don't have a lot of space here. I'm going to take the 3.78, I'm going to multiply that by 25, get that out of the denominator, and then I'm going to divide that by 3 times 18. I'm just going to put it in parentheses, and that'll give us our K value. Okay. All right, then these always ask you a secondary question basically to use your equation. So then it says find R, so R is going to be our variable. I know K is 1.75 from what we just did. T is 4, S is 12, and V is 4 also, but just don't forget the V is squared. So when you put that in, you're going to have to put 4 squared. And then however you want to do it, I'm just going to type it right in my calculator. 1.75 times 4 times 12, and then divided by 4 squared would be 16. So then in that case, R would be 5.25. This would be the actual answer to the question, but we had to do those steps in between to get there. Does anybody have a question? Okay, now this guy, number 18, this is going to go back to our radicals unit. And I'm just doing an equation, and you're thinking, Miss Gordy, there's no radical in that, but a rational exponent, like a 4/3 power, that is a radical. But what I want to do here is solve this equation for x. What is the first thing I should do? Should I distribute? Like, what should we do? Yes, do not distribute, you want to divide. So take 96, we're going to divide it by 6. Do not ever distribute a number into some parenthesis that has any kind of exponent. So this is really 26 minus x to the 4/3 power equals 16. Okay, now let me have you guys look at this real quick. You can just cancel out that exponent by taking both sides to the reciprocal power, all right? So I'm going to take both sides to the 3/4 power. And you don't have to do this by hand. You can use your calculator because you're going to have your calculator on the whole test, but I want to say something to you about this. If I actually were to write this out, just real quick, I'm going to do my bottom out. This is the 4th root of 16 to the 3rd. I'm just going to do 16 to the 3/4 power on my calculator to do that. But what I'm trying to make a point about, I introduced a 4th root. So I need what to go in front of that? Like if you introduce a square root, it's the same as a 4th root or a 6th root. What do you have to put in front of that radical? What symbol? Plus or minus. Okay, that's all I want to say. If that numerator is even, you need a plus or minus. If the numerator is odd, you don't need that. Because like if I take a cube root, we don't need a plus and minus symbol, or if I take a fifth root, we don't need a plus and minus symbol. But square root, fourth root, you need a plus and minus, because this is actually going to have two answers. So you can just do, if you want, on your calculator. I know I had you guys do a lot of these by hand, but if you want to do 16 to the 3/4 power, you can do that on your calculator, which I'm not on the screen again. I'm tired. All right, but make sure this is plus or minus 8. All right, so I'm going to move that 26. I'd get negative x equals negative 26 plus or minus 8. And I'm going to just divide everybody by -1 real quick. So that'd be 26. It would still stay plus or minus 8. So then you just do 26 plus 8 and 26 minus 8. So 26 plus 8, let me think about that for a second. It should be 34, right? And 26 minus 8 would be 18. And that actually has two answers. You don't have to worry about extraneous solutions for this type of a problem. It's not going to happen. Both of the answers will work. All right. Now, this guy's also from the lovely radicals unit. I have cube root of 112x to the 17th divided by the cube root 7x to the 4th. Divide and simplify. So, do I need to rationalize the denominator, or what would you do here? Do what? We could do factor tree. What should you maybe try to do first? Okay, I'm just trying to save you some time. All right, if they're both under a cube root, right? I know it's written separately, but this is totally legal. You can pretend these are both under one cube root, as long as it's the same type of root. I'm just trying to save you some time. Okay, I'm just going to do some exponent properties just in case. It might simplify this a little bit. So I'm going to take 112, I'm just going to see if that's divisible by 7. It probably is. It is. Okay, so if I take 112 divided by 7, I get 16. All right, now just exponent properties here. Where do you have more x's, the top or the bottom? How many more? 13, right? You can do 17 minus 4 to figure that out. Now, if I simplify that first, this is really my problem. This is my problem. Instead of, we don't have to rationalize the denominator because the denominator completely canceled out. Now, we do have to break this down a little bit, but that's a whole lot easier to deal with than what it was looking at initially. Now, 16 is not a perfect cube, so let's see if we can, if you want to do a factor tree, you have to pull numbers out in groups of 3, or if you want to find the biggest perfect cube, I've got those numbers listed up. That was on that little yellow card. I'll give that to you guys on the final too. That's how I do it. I just do biggest perfect cube, which would be 8. And then I break down the exponent out of 13. That's not a perfect cube because 13 is not divisible by 3. So I'm going to break it apart, just using exponent properties. I'm going to write x to the 12th times x. I'm just trying to get an exponent that would be divisible by 3. If I add those exponents back together, that gives me what I had for the x to the 13th. We're just trying to remove anything we can. If you want to break down the 16, do 2 and 8, and then you got 2 and 4, and then you got 2 and 2. If you want to do the factor tree, completely fine. You're just looking for a group of 3 if you have a cube root, and you're going to see I'm going to get the same thing with what I did too. You're going to pull out a 2, you should still have a 2 left underneath. Here, perfect cube root of 8 is 2, but I still have the 2 underneath. Now for the x, you're just going to divide the exponent by the root. So 12 divided by 3 is 4, and then the 2 and the x are going to stay underneath. So my actual answer here, excuse me, I got 2x to the 4th, and then left under the cube root, we have a 2x. Does anybody have a question? Okay, now, This is like very beginning of the semester from our functions unit for number 20 here. We are just going to literally plug these functions in. So this says 3 times f of x. So 3, and our f of x is x squared plus 3x minus 10, minus 4 times g of x, and then up in the directions it tells us g of x is x minus 6. All you have to do, we're just simplifying this, we're not factoring anything, we're just going to multiply this out and combine like terms. So I'm going to get 3x squared plus 9x minus 30, and then minus 4x. Negative times a negative is going to make a positive 24. To answer the question, don't factor anything like that, we're just going to combine like terms. So 3x squared, I only have one of those. For my x's, I've got 9 minus 4. So we have 5 x's, and then for our variables, we have, or for our constant terms, we have a 30 and a 20, or negative 30 and a 24. So negative 6. Don't try to factor or do anything like that. That's just your answer. You're just multiplying and simplifying is all we're doing. All right. Now, the next one, again, you won't have to actually physically graph anything on the test. It'll be multiple choice. So you'll get like 4 graphs to choose from. So I'm just going to write you a little note about what these look like here. If you just have a plain cube root of x, that's not what I have a negative cube root of x here. I just want to show you the shapes. All right, so cube root of x, because you can take the cube root of a positive number and a negative number, the sketch of the graph looks like that. The front side is like similar to a square root. The back to the left and down, that's because you can take the cube root of a negative number. Now, the one we're actually going to graph here in a second, I'm just going to give you a shape. If you have a negative in front of your cube root of x, the way that changes the shape of the graph is it just flips over what I just showed you. Like that's the general shape. So you're just going to have to do the general shape, and from the equation it's going to shift a little bit. This works like every single graph that we've done the whole entire year. With the x is the opposite of what that looks like. It's what sets that equal to 0, which would be positive 2. Outside the root, that is just copy that, and that's a plus 3, so positive 3. That's your y. What that point gives you is that point in the middle. So I'm just going to plot that real quick. So I'm going to go over 2, up 3. And then again, you guys will just need to know, okay, if it's a negative cube root, there's the middle. And then it's going to swoop like back to the left and up, down to the right and forward. You won't have to actually graph it. You'll have to pick out which graph has the right middle point and which one has those curves go in the right direction. Bless you. All right. See, we're just going to do a couple more and then I'll be quiet. Write a function that represents the value y of x, or value y after x years of a new car that is purchased for $21,000 and depreciates at the rate of 6% per year. This is a general exponential. Okay, so normally when you purchase a car, the value of the car depreciates, which means it goes down. The A is going to be your initial amount. So in this problem, that's just what you paid for the car, which is the $21,000. Now, the B value is your growth or decay factor. So it depends on what you have. I'm going to write both here. It's 1 plus the rate if you have growth. It's 1 minus the rate if you have decay. So you're going to have to decide from the problem what you got going on. Depreciate means decrease. So for this particular problem, I want the 1 minus the rate. Okay, now you have the rate as a percentage, so don't forget you want to think about that as a decimal when you do this problem. So it's like if you had 100% on a test and you took 6% away, you'd get a 94, right? So this would be 1 minus 0.06, which means the car holds 94% of its value, but it does go down. So to write your general equation, we should have a y and an x. So we're going to have y, and then you just have the 21,000.94 to the x. It doesn't ask us to calculate the amount or anything like that. It just asks you to write the equation. So you got to decide growth or decay, 1 plus the rate, 1 minus the rate, the value of the vehicle is the A value. Okay, now I want to have you pay special attention to this question here. So the way the answer is written for this problem is an exact value. I know it says round to the nearest thousandth. Let me, I'm going to say exact value. So I want you to know how this is written on the actual test. Okay, first thing, do not multiply the 4 and 10 together, all right? In your order of operations, you got to do that exponent first, and you can't. So you actually want to take and divide by 4 as your first step. So I'm just taking 624 divided by 4. You're going to get 10 to the 3x power, and then this is 156. Okay. I have my variable in an exponent, right? So I got to get that exponent down on the level with the rest of the question. What do I have to do here to get that exponent down? Remember? Yes, we're going to do a log. 10 is the base of your log. Base of your exponent, you're just going to swing this over. It's going to become the base of your log. All right, so when you do that, you're pulling that exponent down on the level with the rest of the question. The base, which was 10 for that exponent, I'm going to write the word log, becomes the base of the log. And then just to review this with you, the log with a base 10 is a common log. So if you don't have a little subscript, we could actually just write log of 156. We don't have to write the subscript if it's 10. You can, it's not wrong, but just a little review to remind you guys of that. If you don't have a subscript, it's assumed to be base 10. The only other thing I would do here is divide by 3 real quick. And so I just wanted to show this to you because this is how it's written in the multiple choice. It'll, instead of actually doing that in the calculator, it leaves the answer in this format. Does anybody have a question? Okay, we're going to do 2 more and I'm going to shut up. All right, so graph the function. This guy is a square root. So let me just give you the 2 parent functions. If you just have a square root of x, we have this restricted. It's just the top half of a sideways parabola. If you have y equals negative square root of x, it is the bottom half of that same sideways parabola. This is how we graphed all of them. If, and don't, maybe, this is not going to be how it is on the test, but I just want to show you. If you actually had plus or minus x, like that, the reason we restrict it, the function would look like this. It's a sideways parabola. It's an inverse of a quadratic. The reason we restrict it, this is not a function, and it doesn't pass the vertical line test. So that's why we just do one or the other. Now, in our case, for this graph, we have negative square root of x minus 1 and then plus 2. And the reason it doesn't flip back like a cube root, you can't take the square root of a negative number because that's going to give you I. So just that's why we don't have a flip back. You're just going to either swoop up to the right or down to the right. In this case, it's down. And so just opposite copy, the starting point should be 1, 2. So I'm going to go over 1, up 2. And it's got a little negative in front of this, so that is the bottom half of that sideways parabola. So just kind of a sketch goes like this. You're going to need to know the first point, and you're going to need to know kind of the direction it goes. Now, in terms of your domain, it says state the domain and range. So I don't touch any part of that graph till I get to that first point. You would have a bracket here because you actually have that point. That x value is 1, and then it goes to the right forever. For the range, and this is always tricky, if this is pointed like gradually to the right and down forever, so you want to start your interval with the lowest possible value, which is negative infinity. And then I would be approaching this from the bottom. You would stop touching the graph at the y-coordinate of that point. There's no y-coordinates above 2. And again, you'd have a bracket on that because you actually have that point that you touch. Let me flip back for 1 second because I did not do the domain and range for this one on 21. Now, real quick, these are easy. So both of these, it's just negative infinity to infinity. It goes left and right forever, up and down forever, but I totally did not do that on number 21, so maybe just go back and do that real quick. So just left and right forever, up and down forever, the cube root, or if we flipped it over, they all have the same domain and range for cube roots, whether it's positive or negative. Okay, we're going to do one more problem, then I'm going to be quiet. What we have here is a fourth root. And the one on the test is like this. It'll be perfect. So you can take the fourth root. You could use the little yellow card. I got the numbers up on the board. If you guys see the 256, this is a perfect fourth. This actually just comes out as a 4. How do I simplify the exponents on the variables here? I've got x to the 24th. Like, what would that come out as? 6. Yep, you just divide. It'll be perfect 4, 28 divided by 4, exponent divided by the root. This would come out, oops, y to the 7th. And that's your answer. And you don't have to do anything else there.